Previously, we saw some code to find the last node on the list and use that to append to the end of a function. And now we're going to think about how could we write some code to append a list to the end of another list. So here's the code to find the last list on the node. So now we want to append list A to the end of list B. So we already have find the last node on the list. So we want to use this to append list A to the end of list B. So we have to think about like what's the code that we want to consider in this case, and how's it going to work? What's it going to do for us? So again, we're going to use our design strategies, try and break it down into pieces, and think about what we need to do for each piece. So what are the cases we have to consider? So the first thing we have to think about, like making more than one list, right? So we have to have, so let's think, so I guess both lists could be empty, or we could have just one of them could be empty. You know what? Let's not worry about all that right now. Let's just assume both lists exist. We could write all that code, but for now, I just want to think about the mechanics for this. So if both lists exist and we want to append list A to the end of list B, we have to create our two lists. So let's say that we have here, we have a pointer to list B, and let's say that is a list that has on it two nodes that looks like this. And let's say it has these values 2 and 4 on it like that. And so list B points, that's the head pointer, like that. And then we have a pointer to list A because we're appending list A to the end of list B, right? And so this similarly here, let's say this is a pointer. We have a list and we have some other values here. Doesn't matter how many we have, right? Could be one, could be more. And we're assuming that it's not null. Okay, so let's say we have, this is 1, 3, and 13. Okay, just some values. What we want to do is we want to do that. We want to make end of list B point to the beginning of list A, like that, because we're appending list A to the end of list B, right? So here's the end of list B, and we're appending list A to the end of list B. So how do we do this? Well, first of all, we have to find the end of list B. So that's not so hard because we already wrote that. Find the last node on the list. So what we can do is just find, in our case, we just have one case. So what code do we have to write? So down here, we're going to find the end. Let's see here. Find the end of list B, and then make it point to the first node of list A. So it doesn't seem like this will be too difficult. So find the end of list B. This is going to be what we saw up here. We already have this, so we could just use this. So pointer, node star, pointer to list B is equal to pointer to end of list B equals find the last node, and this has to be a pointer to list B, like that. So we find the end of list B. So in this case, we're making a new pointer here, and we're calling this pointer to the end of list B. So pointer to the end of list B. And so that's a pointer, and it points to the last node on list B, right? That's what this does. So When it points to the last one, then we can take that arrow p next, which is that, and make it equal to address of this node, which is stored here. So simply make it point to the first node of list A. That's just going to be pointer to the end of list B, arrow p next, go into the box, find this pointer, this next pointer right there. That's the thing that has to be changed, right? Make that equal to pointer to list A, like so. And then that's it. So that thing seems really straightforward. Actually, here, the part that's a little more difficult for us is we have to take our existing code, and using our existing code, we have to make two lists. We have to make this list. We have to make list B right here. And we have to make list A over here. So how can we use our existing code the best way to make two different lists? So I encourage you to stop the recording, go into your source code right now. Here's our source code, and think about, like, how can I do that? Here's the code to make a single list. How can I make more than one list? So pause the recording, take a moment, think about that. All right, I assume that you've gone and thought about that. I hope you did. Welcome back. So I'm going to think out loud about it for us. Basically, I could take this, enter the numbers for a list followed by -1. I could do it once with a pointer to list A, and then do it a second time for pointer of list B. But it seems like, you know, when I copy and paste the exact same code, like, that's a little bit of a problem, isn't it? I probably shouldn't be doing that. Maybe what I need to do, I need to put this into a function, right? So it prompts for it and it does it. So let's write a function to do this. So prompt for and read in input and store on the indicated list. So this is a function, right? So we'll call it get input and store on the list, and we'll send it, in this case, p head. Okay, and actually, since we're having two lists, so we'll say p head A. That's a pointer for the head of list A, so this will be p head A. So we're going to send that one, right? And now we want to take all this code and put it into this function. So that's going to be up here. So I'm just pasting it all up there, and we're going to make this. Let's grab this, put it up here. This is going to be our new function. Leave 2 spaces after it. It's called get input and store onto the list. So it looks like that. So get input, store on the list. This is going to be void. And then what's the type of p head A? Well, it's a node star. And not only is it a node star, but in this case, it changes, right? When we come in, it's set to be null here in main, but when we come back, it's going to change. So the type of it is node star, but it's not a value parameter, it's a reference parameter. So it has to be node star ampersand. So same rules. You want to make it a reference parameter, you want the change to be reflected back to the caller, you have to put an ampersand between the type and the name of the parameter. So we're doing the same thing here, and enter the numbers. We come in, so p head A. In this case, since everything in here is just called p head, we'll just change the name here to be p head, and then we're good to go with the rest of the code down here. And this is the end of get input and store on the list. Okay, like that. Okay, and input, we're getting a complaint because input's not declared here. So we have to do int input, declare that to be used. Oh, ptemp and phead. So phead came in there, but ptemp didn't. So we need that. So node star ptemp has to be declared for our use in here. And now warning equals 0. That's fine. Okay. Now down here, because we're using ptemp up there, we don't need ptemp here anymore. So get the input and store on the list. So we send it p head A, which is going to be this. And now here we're going to display list p head A. And before we go on to make our second list, let's test and see if this worked correctly. So here, changing the old p heads into p head A. Display the value stored in the last node. Well, we already know that that works correctly. We don't need to test that anymore, right? So get the input into this list, display the list, find the pointer to the last node. Okay, so that we're going to use, so we'll just leave that there right now. And input, we don't need it here anymore because we're doing that in this function. Okay, let's see if this works correctly. So let's run this and see what we get. So some numbers for the list. So 3 and 5, -1, we get 3 and 5. Looks like it's good, right? So it looks like it worked correctly. Notice that if we change this, if we took the ampersand off, right? And then we go and we run it, it still compiles. And we're like, oh, this is fine. We didn't need the ampersand after all. 3, 5, -1. Wait, where's my list? What happened, right? Just that ampersand, because we're passing it in as a value parameter. So what we pass it, we declare the head of the list out here. We pass it here. We go in and we catch a copy of it. We use the copy of it, build the whole list using that copy. And when we return, it goes out of scope. So that list has been allocated. That list is still sitting there in memory, but we lost our ability to access it. So we come down to here, and p head A is still going to be null because it hasn't changed. Only the copy changed, right? So that's why that ampersand is really important right there in this situation. Okay, so now that we've done this, now we can easily make a second list, right? And then we're well on our way to do what we'd wanted to do, which is to append one list to the end of another one. So p head B. So while read an input and store on the indicated list, so we can do it twice. So we can do it here for the first list, and we can do it for the second list. So pointer to list B like that, and we can display list A. So cout list A is, and display list A, and we could do the same thing with list B just to verify that everything is correct there. And list B is, and list B like that. And so let's just check that part before we go on any further, right? Make sure that it works for both of the lists. So let's again run this. So we'll go up and run it. And it's prompting us for the first one. And in our test input, we said 2 and 4 on the first list, 1, 3, and 13 on the second, right? So 2 and 4 on the first list, 2, 4, -1, and then 1, 3, 13. Okay, that's what it was. And then 1, 3, 13 on the second list. List A is 2, 4. List B is 1, 3, 13. So we're good to go, okay? So now what we want to do is we want to append list A to the end of list B. So we get a pointer to the end of list B. So let's see here. Find the last node on the list. We send it list B. We're finding a pointer to the end of list B, right? So append list A to the end of list B. So find the last node on list B, okay? And then we saw what the code was to actually connect the last node of list B to the first node of list A. And that was just a single line of code. We saw here, once I have a pointer to the last node on list B, connect it to the front of list A. And that's just going to be this, right? The pointer to the end of list B, P next here, equals a pointer to list A. So pointer to the end of, we called it the last node of list B. So let's be consistent here. Pointer to the end of list B equals, or we get it, and pointer to end list B arrow next equals pointer to list A, P head A, I guess we called it. So a few translation details here, right? Now, display list B which should have all the nodes on it, right? So if I call display list and send it the pointer to head B of the list, it should have everything on it. Okay, here we go. So the first list, list A, has 2, 4, and the other one has 1, 3, 13, and negative 1. So 2, 4, 1 through 13, and then we have 1, 3, 13 for list B, followed by list A, the 2 and the 4 is correct, right? What do you think is going to happen if I go back and just print out list A? Only. So list B has everything together. So if I do display list P head A, what do you think the output is going to give us? So list A only has, and then we print this out, right? So think about, what do you think that's going to be? Well, we can look at our diagram. Let's see. Pointer list B, so these are all connected. Oh, but look, the pointer to list A, it still points to this node right here. This happens to be in the middle of another list now. Well, that's okay. It's just going to start from here, give us the 1, 3, and 13. When we run this program, like, it's going to work correctly. So if we run this, now we're going to get, here we go. We had the 2 and the 4 for list A, and then 1, 3, 13 for list B, prints out both of them, 2, 4, 1 through 13, and then add the 2, 4 to the end of 1 through 13, and print out just list A, which is still 2, 4, so it is doing what we expected. The implication here is you could have a long list, and then you could have pointers into the middle of the list as shortcuts. Like if you had a long list for all these dictionary words, you could have a pointer into them, to like a pointer to all the words that start with a B, and the pointer to all the words that start with a C, and etc. Pointers into the middle, and that is one of the things that a data structure you could talk about called, well, never mind. But that could be something that's useful.